let me start. There we go. We're up.
All
We're
right,
off.
great.
Thank you, everybody. Go for it.
Great. Thank you very much, Ed. I am Bob Hardaway. Can you guys hear me okay?
Yes, we can.
Great, thank you. Welcome to tonight's, BI in Santa Barbara meetup. The topic tonight is, Apache Kylin and extreme OLAP, achieving sub-second response on massive data sets, or as I like to call it, you can have your BI cake and eat it too. So I'm going to be your host, your guide tonight. I've got a number of slides. I will try and get through them pretty quickly. I have a demo of the product as well, but I'd also like to encourage, interactive conversation. If you have questions, I for one believe, Kylin is a very, new approach to solving problems that we're all familiar with. And if there are things that don't make sense, or you just would like to better understand, feel free to jump in. We'll also leave some time at the end, for formal Q&A. All right, so my agenda tonight is really pretty simple. I'm going to provide sort of an update or a status on OLAP, my view of where things stand. From there, I'll go into Apache Kylin, how it works, what are the problems it solves. And then we'll jump into a demo of building these extreme or distributed analytic engine on top of your traditional, call it OLAP data, and driving better, more consistent, and very much faster BI results, right? Insights, queries, and just getting answers to your business more effectively. And like I said, then we'll finish with some Q&A. This is my view. Daniel, who joined early, was discussing his experience. To me, the term OLAP simply means, online analytics. We have lots of systems that do OLTP. That is transaction oriented. That's what makes the world go around, from Amazon to Walmart. After we finish, providing goods and services, OLAP and BI take over. And, to me, it's equally as important, maybe more important these days, to be able to analyze that data and provide results, and more predict or better help your businesses decide what to do in the future. So OLAP, the concept of maybe traditional warehouses and ETL, that may be dead or not in vogue these days. But for me, the process and the need for this type of analytics is greater than ever before and growing like crazy. So, I like to put technical, very complex solutions into non-technical business terms. What does OLAP do, right? What questions can it answer? You are trying to answer for any business just fundamental statistics, right? What is my profit for the product I'm selling, beer in this case, in the US this year? What are the 5 best-selling products in each city? These questions just go in every direction, deeper and wider throughout your business. A relevant one, maybe topical today. Do I have enough toilet paper for a pandemic? Gets a little interesting. Why do beer and toilet paper sell together? Again, if you're kind of a historian or a nerd like me, you will maybe get the analogy or get the reference there that many years ago in retail or in consumer goods, OLAP and this type of analytics was able to discover relationships between products that are available in your grocery store. And beer and toilet paper had this strange affinity. And, it's pretty simple. I think a lot of maybe males of our species go to the store for beer, and they get told by their better half that we need toilet paper. So it's kind of a goofy analogy, but you see the potential to drive the way you organize your products, who you market them to, everything about your business based on what OLAP can provide. And again, these answers just go deeper and wider. And the challenge that OLAP suffers from is that, data is growing exponentially. It's growing internally within companies, and it's growing from the standpoint of commercially or publicly available data. You also have this pressure of your business needing and wanting better answers faster. So traditional OLAP, I use the word traditional quite a bit. It had some real strengths. This map shows where it focused. Where it didn't focus, and where we have struggled with OLAP solutions, is that OLAP doesn't like data to change, right? If I'm assessing business sales for the Northeast last year, those are all statistics that are read only. They are fixed and known, and there's no need or thought about changing them. OLAP solutions have traditionally been deployed on a single machine. And so scaling one server or one OLAP cube has its limits. Transactions are just fundamentally not a part of the OLAP world. They are absolutely critical if you are making an order on Amazon, and Amazon flips up and, records the price as $20,000 and not $200. So that's a transaction. OLAP has no capabilities for that type of work. So the challenge today is that a lot of these strengths that OLAP has always been good at are still there, but these weaknesses, these drawbacks are becoming more and more apparent and limiting. This slide, there's a couple things here that I've already talked about, but again, you're overwhelming these traditional OLAP systems. Now we start to get into less business oriented and go into, the under the hood of what a OLAP and BI system is. And you're starting to see compromises, right? Concessions. I have represented or worked with many, analytic teams, marketing teams, and they are frustrated by a lot of the answers or the pushback they get from their technical IT teams. They hear things like, you have to decide which dimensions are of value, you can only have 5 or 10, and you have to make that decision right now. What we found with data is that exploring data is the great way to figure out what the value is. And an OLAP system doesn't really support that. You have to pick your schemas, your cubes, and your dimensions and measures ahead of time. And if you find out you're wrong, it's very costly and time-consuming to correct from those types of problems. You also have a tremendous amount of effort from IT to the business to keep these systems running. I like to just kind of joke, this is my humor, but I've never ever seen query performance get better. If I'm using, SQL Server Analytics against a large, SSAS deployment, and a query takes 10 seconds on Thursday, I hope it takes 10 seconds on Monday, but it's never going to take 7 or 8 because the evolution, the amount of data, the system itself is always going to struggle. Okay, so just again to kind of frame this, you have kind of four main traditional OLAP platforms. These are, what I refer to as stack vendors, and they provide very robust and feature-rich solutions to this OLAP problem. I think it's kind of interesting that, three of the four, Microsoft, Oracle, and IBM, are also the dominant providers of, those OLTP and CRM and those systems. And so you have a suite of tools here that are designed to work together. They're not necessarily designed to be flexible and address some of these problems or these, the structural flaws that OLAP has suffered from. Okay, a little more on just the current state. The data lake, whether it's big data or just the ability to sort of land all of your potentially interesting analytic data in a single sort of low cost but very accessible repository. I have been a student of big data, and as the fad or the excitement sort of wanes, what I think remains is you still have this vast amount of data, whether it's cloud-based or based on a Hadoop or other, MPP structure. You still need you need this capability to manage that data centrally and effectively. And so OLAP has struggled, along with the BI tools, to provide ready access to the big data lake. I think of it as, a BI tool where a user can only assess and comprehend a limited amount of information with a straw trying to find the right, minnow or fish in the ocean. It's just a very daunting problem. And, we haven't really kept up with it. We haven't been able to bridge that gap. Okay, so sort of leaving the business discussion or, the why we're doing these things and delving into the how it's done. An OLAP cube is just a fundamental unit of work for the data warehouse, for the analytics team. And it's really pretty impressive and fundamental. I'm going to organize the data so that I can answer that question from the business, beers sold in Los Angeles in June. I can answer it as quickly and effectively as possible. And so storing data by these dimensions, these filters or these keys that we want to slice and dice our data by, is a great way to build an OLAP solution. 90 beers in Los Angeles in June falls out of this cube very fast and effectively. Cubes are built on top of tables. Tables are the fundamental unit of any data management system. And what I'm able to do is select, tables representing things like customers, store locations and dates, and connect them through a series of join keys to my facts. My facts are measures or numbers that represent those transactions. So revenue, sales amount, supply costs are great examples of those measures that we want to aggregate and start to draw conclusions from. This just gives you a little more depth. Again, I'm sure for some of you this is kind of simplistic, but for me it just sort of helps frame the discussion. The vertices in my picture are those dimensions. I've got New York, Los Angeles. Those are regions, or those are geographical. I've got dates, and I've got categories, types of products. The measures are the data that live at each of those intersections, and those are the interesting things that we're going to start to do calculations on. Okay, last depth on OLAP. I'm going to give a little bit of description of a couple of the key features here. Not going to describe it completely, but suffice it to say that when you hear terms like cube and roll up and pivot and slicing and dicing and Julienne, you're talking about key OLAP operations. The roll-up is just what it sounds like. I'm going to take data from the level of maybe a month or Los Angeles, and I'm going to start to do what's called aggregation. So I'm going to pre-calculate or actually answer some of those questions in the model or in the data itself. Again, my goal is to be able to anticipate what my end users are interested in and get them the answer more quickly. So a roll up from Los Angeles 90 in June becomes for Q2, Los Angeles sold or produced 270. Just as roll up is a summarization or kind of moving up in granularity, less granular, drill down is the opposite. And so the ability to go from those months down to days or from New York to different areas in New York City is the ability to drill down. Drill down is difficult within a traditional OLAP system because the amount of data that needs to be tracked just starts to overwhelm the system. All right, just to see if anyone is paying attention, slicing and dicing, definitely features of OLAP. Julienne, not a feature. Okay, hopefully that was so informative, but we're going to switch gears and move directly into what the Kylin Apache project provides. Again, I like to think of it as founded on these key principles that are tried and tested and true, but also built from the ground up for scale and speed. Little bit of history on Kylin. A lot of the key sort of data and analytics projects that Apache now manages had their origin with the tech companies, with Google, with LinkedIn, and in the case of Kylin, with eBay. You're probably familiar with eBay, and so you can imagine that back in 2010 and earlier, eBay was experiencing massive growth, and they were struggling to keep up with these analytics needs. They were using traditional OLAP engines, and some of the things heard in the IT hallways of eBay were, okay, we're going to rebuild the cube from, last month because we forgot a dimension, and we're going to kick off the build tonight, and it should be done in 72 hours. That was the state of things back then. eBay, as a very tech-founded company, has the opportunity and ingenuity, the innovation to go ahead and start from scratch. Put the business problem on a whiteboard and look at ways to just dramatically change what they had been doing. And so they did that in 2012-13. And in 2014, they took the step of releasing that baseline source code as open source. Open source has become, to me, gone from sort of a one way of procuring software to the dominant way of building these systems. And so they pushed Apache Kylin out to open source. Apache puts any project through a vetting known as an incubator process. It's very rigorous. You have to prove that your team has adequate and good source code control. You have to go through a number of security and other checks to make sure you're introducing code that lives up to its potential. And you have to prove that people are contributing to that baseline. Apache has literally 20 or 30 or more thousand folks that contribute that are called contributors to the baseline. And you also have folks that take a even more active role in maintaining the product itself. Kylin moved through this process very, very quickly. To compare, Apache Hadoop, and HDFS took probably twice as long, given the nature of their fundamental changes to get through this process. But, Kylin got to where it was deemed a top-level project. And then in 2016, the company Kyligence was formed. And the way I like to just describe it is Kyligence wants to be the Databricks of Spark or the Confluent of Kafka. They really just want to become the stewards and the overall guiding influence on the open source baseline. Okay, modern OLAP, just conceptually and very high level, we used to just try and create cubes that would run on a single server in a single process space. And like I've mentioned, that has challenges. That becomes problematic because bigger is not often better. What Kylin does is provide an interface that is the same as that single cube. It's logical, so your user, your developers are not having to change their approach. But within that logical cube, Kylin takes the initiative to distribute that information across a cluster being just multiple processing spaces. One of the key concepts of Kylin is a cuboid. So literally a small and interconnected set of cubes. These cubes run distributed within this cluster of processing nodes. Kylin is a question or?
Yeah, if you don't mind, you said, does each cube operate in one node, or does each cube span nodes?
So for Kylin, a cube logically is just your point of interaction. A cuboid, which is a subset, I've got some slides that'll explain it in more detail. A cuboid will run on a single machine. A single machine could manage thousands of cuboids. But yes, the cuboid is going to run on a single machine.
Okay, thanks.
Sure. And I'm going to describe what a cuboid is. If you have questions there, don't hesitate. Okay, again, the objectives, the whiteboard that was thrown up at eBay with a bunch of interesting and probably people laughed and said they were crazy, 900 billion rows, 99% of queries in less than 1.3 seconds. It's important to note the 99%. The compromise that Kylin makes is that some queries, very few, ultimately, will take longer because they will not be readily available in that cuboid structure. And the design is that that's okay. If the Kylin system is set up such that the most interesting, the queries that users are running most often are always in that 99%, then it's a win-win. ANSI standard, just the ability to leverage all of the great knowledge, resources, tools, etc., that are built on a standard baseline of SQL. Kylin provides that same seamless interaction. Hadoop native, again, for eBay, all of their source analytics data lived in Hadoop clusters. They, at their peak, had probably 20 Hadoop clusters, each one of which was 300 to 1,000 nodes. An amazing amount of processing power. But Kylin is designed to run co-located on that cluster. Now, I'll mention that Kyligence, the product version of the product, is also expanding that more widely to be cloud native, so to run with typical bucket storage, blob storage like S3 and Azure Blob, and so it's becoming Hadoop native plus cloud native. in the near future, Kyligence will become RDBMS native as well. So we'll be able to interact with MySQL, Oracle databases in a similar fashion. And then MOLAP, multi-dimensional analytics. Again, I get a little confused because we have MOLAP and HOLAP and all of these derivatives. I just keep it simple and say it's fundamentally OLAP, and the first letter is a way of improving the performance, improving the scale. Okay, I'm going to pick it up a little bit because I realize I do want to get to the demo pretty quickly. So I'm just going to give you these 3 slides here. Architecturally, Kylin is pretty simple. The engine is this ability to build cubes on the one side and then to serve or answer queries. The architecture is designed so that those nodes are independent clusters. So one of the capabilities Kylin provides that almost every analytics tool I've ever worked with suffers from is that building, meaning assembly of adding of new data, of new dimensions, of slowly changing dimensions, can happen at the same time as heavy BI usage, maybe 100 or more Tableau or Power BI users. Again, traditional architectures, it was sort of run the update overnight, hope it finishes in the morning, and then let the users come on after that processing was done. Okay, I foreshadowed cuboid. This is a very busy slide, but I'll just summarize it. This is just the secret sauce of Kylin. Under the hood, instead of trying to take that 3-dimensional cube that I showed earlier, which, by the way, a 3-dimensional cube that looks like a Rubik's Cube, I think is very visually appealing. It becomes a little harder when I try and help people visualize a 6 or a 12 or a 20-dimensional cube. So the way Kylin addresses this, scale issue is to come up with this concept of cuboids. Cuboids are just the combinations of possible dimension-based queries that the user could ask for. So in a simple example like time, item, location, and supplier that I have here, those are 4 dimensions. By default, Kylin is going to create 2 to the 4th cuboids combinations. It's going to create a base cuboid that's going to look, for all intents, like that entire set of information. But for performance, it's also going to create smaller combinations. Time and item, supplier only, time, location, and supplier. These cuboids are going to run on that cluster, and if I execute a query that requires, time and location, I'm going to have an optimized cuboid with indices and pre-computation to answer that question. That's fundamentally how I'm going to maintain this sub-second performance when, anyone who's supported this infrastructure knows that the ability to reach into these structures and go deep and collect and aggregate is just a very complex and time-consuming effort. Last slide. If you are looking at this slide, or you heard me say that this is a 4-dimensional model, 16 cuboids, you're probably going to ask, that's great, Bob, but when I have 20 cuboids, that's 2 to the 20th. Offhand, I'm going to bet that's a really big number that no system could handle. So the compromise here is to develop a partial cube or to prune some of these cuboids. Was there a question there? Okay. Again, feel free. But what Kylin will do is it will allow you to determine which combinations are most important. And those will be kept in memory. And the combinations that are deemed lesser priority will not be in memory. Now, again, keep in mind that fundamental to Kylin is this idea of push down or tiered execution. So for those combinations, if I'm looking at C and D or B, C, and D, that query will be answered in memory by the Spark engine by Kylin. If I do need to ask a query of AC or ABC, that's going to be pushed down to the underlying storage. Today, that could be HDFS or HBase. In the future, it will be Spark. The last thing that Kylin does, which again is kind of the secret sauce, and Kyligence is the company that is emphasizing this capability, is that there is an AI component, a learning component being introduced. So I mentioned earlier, my frustration with these designs is that if you ask me which combinations of queries are most relevant before I've even begun to build this system, my answer should probably be, I don't know. What Kyligence does is say, let's pick the most common set now, and then Kyligence will allow you to ingest query logs, to ingest DDL, and other evidence of what your users are actually doing. You can go collect, the query execution plan for all of your Excel users, and you can introduce that to Kylin and have it learn what the right combination of cuboids to keep in memory is. So you're building a learning engine here that will, get better over time. And our goal is to, really dramatically reduce the effort. This is an area where cube tuning and keeping these systems humming is a very difficult, very limited skill set and very time-consuming effort. Okay, enough with the slides. As I thought, I got a little deeper in there than I wanted, but hopefully that provided a good overview. I'm going to jump into a demo of Kylin here. Any questions at this point? I'll take a breath.
This is Ed. Not a question from me, but just giving you a time check that it's 6:35 just now. So we've got another 25 minutes to include for demo and questions and answers.
Absolutely. Perfect. Thanks, Ed. I'm going to demo for about 10, 15 minutes, and we should be good to go.
Excellent.
Okay, so this is the Kylin UI. As I mentioned, the design is to be co-located next to your big data cluster. The UI and some of the maintenance is designed to run on an edge node in your cluster. And then the configuration of our Spark nodes looks a lot like anyone running, a large-scale Spark implementation. So I log in as a modeler, and I'm presented with the UI to get that modeling process started. The first thing I'm going to do is go locate data sources. So what Kylin shows me is data that it knows about that resides on Apache Hadoop. That Hadoop could be Cloudera or Hortonworks. Today, we work quite closely with Microsoft, and so the HD Insights is their branded big data product. And so you as a modeler are going to have access to that data readily at your fingertips. As I peruse or go through the tables, I get some good metadata on what information is available. One of the things that Kyligence, a key aspect, is that it's going to calculate cardinality for me. So again, a cardinality is this concept of how unique is your data. Think of it as, if I have a bunch of sales orders and there's a country field and the country, and it's only data from the US, my cardinality is 1. If I have an account ID, and everybody should better have a unique account, then the ID, the cardinality is much higher. This is important because in this processing and perusing of these cubes, the higher the cardinality, the more effort, the more resource required. So we want to be aware of that information, from the get-go. What I can do is go and access my Hadoop cluster. These are tables that live in Apache Hive. You can see here I've got the same tables. I've already loaded these. But what I can do from here is very easily keep the tables in the cluster synchronized with what's in Kylin. So this can be scheduled, but the concept here is just a lot simpler than it is made in some products to be able to update your cubes, to be able to add new partitions or segments based on new data that has hit your warehouse. Okay, so having accessed the source data, I like to point out that at this point, all I've done is pull metadata into Kylin. The source data still lies in my big data cluster or in my Azure Blob storage. And so the next thing I'm going to do is develop a model, a description, based on that source data. The modeling process is really just designed to be very, very simple and straightforward. I can select a fact table, and then I can add to it lookup tables. Lookup or dimension tables, these are the tables that contain those descriptions like city, state, and region, or date and time. So I select Kylin sales. I'm just going to select account because this should represent the customers that I'm doing business with. And I'm going to introduce a join condition to tell Kylin how to relate these two tables. I'll pick account ID, and you notice that Kylin has sampled that data and is telling me that the combination that I picked doesn't make sense. And that's because I picked part DT thinking it was a part ID, and it's actually a date. What I'm trying to get at here is that one of the other features of Kylin, and really more Kyligence, is a semantic layer. In Kyligence, I can go through
Oops, lost audio.
technical related names and descript, translate that into something that is consistent and much easier for my business users to understand. I'll just foreshadow that that's a huge benefit of implementing Kylin and Kyligence is that I've worked with many Tableau and Power BI report developers. They are very effective. They can deliver very impressive looking dashboards to hundreds of users in hours or days, but they all struggle from consistency of analytic. What is the actual calculation for, month over month profit or EBITDA, right? I find that Tableau and Qlik and even MicroStrategy, as they have allowed calculations for math to be done, that's great because it's fast and easy. That's not so great because it immediately introduces inconsistency. Okay, so that easily, I have created this relationship between my primary fact table and a lookup table. I can repeat this until my entire star or snowflake schema has been modeled. It shouldn't take more than a few minutes. Next, I'm just going to select, for purposes of this model, what are the dimension columns. That's terminology in Kylin for the attributes or for the dimensions themselves. And so I'm going to go through and pick what I think are is going to be interesting for my analysis. I can pick them all, or I can just pick a subset at first, but I'm adding them to the model. I'm then going to pick, well, from the account, I'm going to pick country and contact. Next, I'm going to pick the measure. This is that piece of data that I'm going to want to use to calculate, like the 90 beers being sold in Los Angeles. And so I can pick multiple measure columns here, or I can just start with price. Okay, partitioning is also huge to Kylin and indeed for any distributed architecture. What a partition is a way for the system to better manage the data. Instead of trying to do a lookup against 5 years worth of information, I can create monthly or even annual partitions, and I can eliminate, 80% of the effort to, apply an index. In Kylin, you typically pick your primary date to partition by. You can partition at a year level. You can also partition down to a more granular level, like month and day. I can also add a filter here. So if I've got logic as to how I want that partition to be handled, I can implement it here. And then my last step is just to save this model. The save is actually going to go off and do some of that loading. So I'm going to move back to a model that's already been loaded and that calculation has been done. And so here's the result, the Kylin sales model. Actually, I've missed a step here. Let me step back. Model and cube, those are fundamental to Kylin. In Kylin, I like to simplify it and say there's a one-to-many relationship. Think of a model as a template. You could have one primary team or one individual that maintained those models, that maintained the access and relationship to the source systems, and you might have 10 or 20 or more cube builders. So the goal here is to encourage and actually demand consistency and reuse. So I'm going to have potentially one model or a few models, and then I'm going to build multiple cubes against those models. Okay, I wanted to show a couple other things. We're going to get into actually querying this model, and then I will wrap up. Okay, so the model itself, what Kylin does based on these simple UI interactions is it creates this SQL, which is actually portable, and this is what executes against the source system. So in this case, I'm going to query Hive, and I'm going to collect all of the required dimensions, measures, and I'm going to load them and start building those cuboids. I get an indication of what the underlying storage is here. It shows me the HBase tables that are going to be built. And then I also get this visualization of what the cuboid structure is going to be. Okay. Once I've kicked off that load, that actual building of the cubes, which takes some time. We're talking, minutes to an hour or so. I'm ready to start accessing that cube. And so I can save some queries here, but I'm really just trying to approximate what my BI users are going to need. And so I've saved a few queries, such as, number of accounts by country, and I can just quickly execute that against my data. So Kylin, that query ran very, very fast. I'm not here to say it was that impressive. We're really running against just 10,000 sales orders. But, you can see where the goal is to maintain that type of performance, even at the terabyte scale. Kylin produces some basic visualizations just to help understand this data. Kyligence has taken this and built a product called Kyligence Insights that is designed to be, maybe not as full featured as a Power BI, but very powerful. And then, again, I can do the basic standard here. I can export this information directly to CSV if I want to load it into Excel. But even better, I have some API or programmatic basis or ways to connect any of the BI tools, whether it's through ODBC or in the case of Kyligence, we have added MDX, multi-dimensional, to be able to better drive performance with Power BI and Excel. So the idea is to be able to allow those BI tools to connect and begin to query against this cube. Let me just finish up with sort of the behind-the-scenes maintenance of the Kylin system. Again, I appreciate this because I feel like the eBay guys just didn't want to have scripts or other tools, or they wanted the capabilities to just manage the information here. That tuning of a high-performance Spark cluster involves, quite a bit of performance and settings of different parameters. You've also got these very simple ways to reload the metadata from your source systems as it changes over time. Kyligence has been designed to allow not only for things like slowly changing dimensions, but just for new dimensions, new attributes. I can seamlessly query across 3 years of data, and I can add net profit at a product level, and I can get that query back. Many traditional OLAP systems might struggle with that. If I query against data that didn't exist 2-3 years ago, that could result in an error. All right, good. So I think I will just stop there. I did want to just summarize that, our goal is to literally make this process not much longer than my demo. Obviously, I only joined a couple of tables and simplified some things. But, our goal is to, enable folks to be able to do this level of effort and get to that BI consumption, in hours, in days, not in the traditional measures of months and longer. All right. Let's, I think I had one last PowerPoint. I can make, these links available to you guys if you're interested, or they're pretty obvious. But what I like about it is that, I'm an open source real proponent. I guess I can't play it from the last slide, but what I like is that you can test drive these products, these capabilities yourself. We deploy a Docker image on, that you can get through GitHub. You can see evidence of a very robust and viable community through, Kylin.apache.org. And then, again, Kyligence also offers some free trial capabilities of our product suite, right? Kylin under the hood with a lot of enterprise capabilities, access control, and that automated AI engine that I mentioned. All right, good. So now I will finally stop talking and open it up for you guys to ask questions.
Thank you very much, Bob. So yeah, let's open up the forum for people. And
got a question.
Just before, yeah. So fire away.
You go ahead.
No, I was just going to say. So I just wanted to definitely say thank you, Bob, for going through that in the presentation and just giving us the slides. Are you saying at the end of the when you were talking about the links there, will you be making the slides that you've shown us tonight available for people, and I can distribute them to the BI members? I mean, I know we'll be sending them the recording, but the slides
I
too would be
think
useful.
so. I think so, Ed. As I said that, I need to let Samantha be the guide there. There might be a few slides in there that we would prefer not to publish, but definitely those links. And it was my intent to provide the deck. Let me make sure that's okay with Samantha. But yes, we'll take those steps.
Okay, perfect. Yeah, if you can send that stuff, once it goes through the proper channels, if you can send that stuff to me, I can get it distributed to the rest of the group, etc., for anyone that couldn't make it tonight. So thank you very much. But
Sure.
more open for general questions now, sorry.
I could ask a question.
Yeah, good.
Bob, did you say that the Power BI connector supports SQL and MDX, and is the assumption then that the Tableau connector is pure SQL at this point, no MDX?
Correct.
Okay.
Yeah, there's a follow-up question. Yeah, go ahead.
No, it's okay. I got plenty, but others probably have questions as well.
Well, and Ed, I'll expand a little bit, and maybe people know what MDX is. I'm no expert there, but what MDX does on top of SQL is a couple of things. There's some performance enhancements, but there's also very much a calculation capability, right? And that is fundamental and important to Kylin because, again, for me as a longtime BI consumer, I know that, every Tableau dashboard is only as good and accurate as the consistency of that source. So for us, MDX is a great, it's just a powerful way to not just give people tables and columns and let them figure things out, give them, calculations year over year and things like that, make sure they're using a single source of truth. So.
But it's also a way to really screw up a connector. Back in the day, the Tableau connector for Microsoft Analysis Services suffered because it constantly tried to pull in every single dimension member. And when you had 20 million dimension members, it would spin all day long and all night long for no reason. So it's a sort of a delicate thing. I'm guessing maybe that the Power BI connector might be a better connector or something like that. But I have a follow-up question, and then we'll see who else has questions. If you're storing it in either in Hadoop or in an object storage, those are generally immutable. And if you're doing slow changing dimensions or trying to otherwise expire data, how do you do that in an immutable data store without affecting performance?
That's a great question. You don't. I mean, yes, your statement, Hadoop is immutable. Our assumption would be that, if you want to update records in Hadoop, you would use a capability to do that, such as, new records to represent, updated data. Our capability to handle those dimensions would be through the cuboids. So we could.
Okay, Bob. But the thing is that if you're talking about slow changing dimensions, you have to update the old record unless you're going to leave the expiration date blank. You have to update it. When you bring in a new record, you need to expire the old record by updating that record. So I'm just curious how that would be done in an immutable data store because it seems like it would have to be done. Or first, well, just not to get down into the technical architecture, but does it truly support a type 2 slow changing dimension or even a type 1 where you would overwrite a record in a dimension? Does your cube actually support that?
Yeah, I think, it's a great question. And I'm learning about our product too. So I'm not confident in my answers, but I will say that we are not updating or adding to the immutable data store, whether it's blob or HDFS. So no, we're not gonna go to that length. So in terms of truly supporting 1 and 2, I think you're right. I think there are significant limitations to what we do.
Okay.
So this is Ed again, and maybe that would be something that I'm not putting you on the spot here, Bob, but maybe if it was something that you could do as like maybe a follow-up and at Kyligence to try and get more of a sort of general answer to that one. Like how would somebody go about supporting that type of like type 1 or type 2 slowly changing dimensions, and how could Kyligence or Kylin be used in that kind of framework? Like maybe as an offline thing, and then again, we can send that information around to the rest of the members as well, so people get a better chance to get it like the fuller answer maybe, rather than sort of like putting you on the spot here right now. So if that's possible,
no problem, Ed, and I'll make that effort because I'd like to know more too, so it'll help me. But yeah, let me see what I can come up with, and again, maybe we'll forward that through Samantha. But yes, that's fine.
Yeah, because I'm sure, like for our audience, everyone's in BI, so I often have that scenario where someone will ask me a question about the data that even I've built, and my answer is I don't actually know for sure, but I know someone who probably can find out the answer. So I think that's perfectly acceptable approach. So one question I did have quickly about is a couple of times you mentioned various Microsoft things and Power BI, etc. Is for like end users of Kylin or Kyligence, is it pretty much like a Microsoft shop, or is it beyond Microsoft? I mean, I know we're trying to go into things like Hadoop, and then you mentioned also like S3, which would be Amazon. But is it like the actual products themselves? Like, do they run in do they run on Macs? And if you're an end user, are you just the person who's consuming the end result of all this? So like, would most end users just be Tableau users? And all of the stuff that we're looking at here within the OLAP, the Kylin world, is that really sort of very much in the back end? Or is it, do you get people who kind of like blur that line a little bit, and you have some technical users that are more on the business side and vice versa?
Yeah, I see what you're saying, and I would say there's a very pronounced, chasm there, right? And we definitely, for me, our two probably biggest value adds are this big data or data lake analytics, just being able to reliably provide a solution that's going to, like I said, on Tuesday, you're going to get an answer. On Friday, you're going to get an answer. And if there's 20% more data, the end user should be, not oblivious, right? Should not see that, right? So that scale is fundamental. The community that we are working with is primarily, Microsoft users. Some of them are power users, but I'll kind of I'm not trying to avoid the question, but I'll go back to something Daniel said. With MDX, you might create a pivot table or create a simple work in Power BI, which might result in dozens or hundreds of queries. My finding is that the front end folks, those teams, have no understanding. So I'm trying to get back to your question. I'm not sure I'm doing a good job.
No,
but
I think
we cater
a general idea. Yeah.
Yeah, we cater mostly to that OLAP or that technical team who is just struggling to keep their business happy.
Yeah.
But for me, I find my way into, that Power BI or Excel shop, one, because I want to understand their problems, but two, like I just said, if we got hundreds of SQL users and they're all doing crazy stuff, we're not immune. Kylin's not immune to that as a huge load, right? We think we have much better ways to handle it than before, but we still, need to understand that usage. We need to go to those users. I'll say one last thing, because now I feel like I'm just, I'm trying try to hide the fact I don't have the answer. But this AI engine to analyze what people are doing is really designed to try and fix that, right? You know, or just let's take a look at what the users are really doing and use that deep, that depth of information to tune the system.
I think that I could also maybe help with that, although I'm not an expert in Kylin or Kyligence, but if you can connect Tableau or Power, for instance, if you can connect Power Pivot using either a SQL connector or an MDX connector, and I think I heard Bob say either JDBC or ODBC, that would indicate that you can then connect anything else that is ODBC or JDBC and do a SQL query against the cube, regardless of whether it was a graphic tool like Tableau or just a query tool. You should be able to do that. It would, as long as it supports these standards like JDBC or ODBC, that wouldn't be a problem. Yeah. And that's the case with any cube. If you've got an MDX tool, you should be able to connect and query it. If you got a SQL query tool, you should be able to connect and query it. If you're a power user and you don't want to just do drag and drop.
Yeah. Okay. Cool. No, thank you very much.
That's fair, Daniel. Thank you.
Yeah.
Recognizing that we're pretty much on time now, so unless anyone has any particular final sort of bursting questions, a couple of things I just wanted to just finish up with. First of all, again, thank you very much to Bob and Samantha from Kyligence for coming along and giving us this overview. Once we're all done here, I'll send the recording round to the BI group and follow up with the slides or any of the follow-up responses from Kyligence related to the questions tonight. For the rest of the BI members, a couple of things I wanted to mention is that next month's meetup, we're putting together the content for that, and it's going to be very similar to the presentation that I gave last month. It's really, we're in discussion with a company, someone who's a BI member at a company, for them to come along and give us an overview of their particular BI setup and their particular BI tool stack at one of our local companies within Santa Barbara. So once we get that aligned, I'll update the meeting invite for that for November, and then coming December, we're thinking that we'll just skip the December one, so everybody takes a break for the holidays, and then we'll meet up again in 2021, which is a brand new year. Hopefully, things will be better in 2021 than 2020. And one thing I would definitely mention is if anyone has any topic suggestions or topic ideas, or if they have other vendors that they're particularly using themselves and they think they'd be useful for the general group at the BI meetup to get introduced to those vendors as well, similar like we're doing here with Kyligence, or in the past like we have with Looker and Snowflake, then again, let us know and we can try and organize and get some future sessions set up with those. But other than that, I think I will finish off the recording in case I forget to do that.